So I'd like to talk about a new magnetic separation method using magnetic nanoparticles for cleaning up oil spills. So I'm going to talk about why we're doing this work, the prior work, requirements, a 5-step process that we have for doing oil cleanups, and conclusions. Basically, I have 3 videos that I'd like to show you. So it was motivated by the large oil spill last summer, or a number of summers ago, BP oil spill. And I looked back at the prior work, which I was familiar with anyway, but basically most methods that have tried in the past use electromagnets, which is a little crazy to put them into an ocean environment. And to generate something like a 1 Tesla field, you'd need a electromagnet that weighs something like 10,000 pounds to generate a 1 Tesla field with lots of copper wire and iron. The secret really is to use permanent magnets, which are much more compact, and you don't have to worry about any safety hazards of electrocution or shocks in the water using high voltages and high currents. Just to show you that you can have magnetic fluid, so that's a ferrofluid or a magnetic fluid. The magnet was turned on. Now we're going to turn the magnet off. And these are permanent magnets, by the way, that you can turn on and off. And then it's released. There we go. So the 5-step process basically includes, let me see, do I get a pointer here? No, I mean a light? There we go. Okay, thank you. Okay, so the first step is to get the oil water collection and transfer from the ocean into a facility on a boat. The water environment is too turbulent, and we don't want to lose the oil, letting it sink. So the first thing is to use conventional technology and get it all onto a boat. That's step 1. Then you have a choice to magnetize either the oil or the water phase. But since there's a lot less oil in the ocean than there is water, we chose to magnetize the oil. And we do that by introducing magnetic nanoparticles that are oleophilic, is attracted to the oil. And then we have a first magnetic separation to separate the 2 phases by having a facility which has permanent magnets as opposed to an electromagnet, and that you will see in the videos that I'll show that the magnetic fluid, that is oil, will immediately go to the top of the magnets, which is above the level of the water, and it separates the oil and the water. Once the oil is separated, then we use suction pumps to transfer the magnetic material into like a pipeline, which it passes through an HGMS unit, that's high gradient magnetic separation. And it'll take the magnetic nanoparticles out of the oil and for reuse. So it's important that we reuse them because they're expensive, and we also don't want to contaminate the oil. So now we have pure oil, which can go to a refinery or for storage. We have pure water that we can put back in the ocean. We have magnetic nanoparticles that we can re-inject into the next load of oil. So that's step 4. And then the last step is to store the oil, as I've said, transfer to a pipeline or refinery, return the pure water to the ocean, and reuse the magnetic nanoparticles. All right, so this is our video with the test facility. We're putting in water. Here is the permanent magnets. These are 6,000 Gauss strength, so it's 0.6 Tesla. Okay, now we're introducing some magnetic fluid oil. And you see that they immediately climb above the surface of the water, forms these sort of spherical with spikes magnetic fluid on the tops of the magnets. And you see we can inject them here, but the magnets are very strong, and they attract the fluid to flow through the water and then jump above to the top of these magnets. Now, To get them into a pipeline, we would use a suction pump, and we can suck each of these tops of these magnets with magnetic fluid and suck them into a pipeline. But instead, we're going to first put in a Halbach array. Halbach array is an array of magnets that has a net magnetic field on one side, in this case, the top side. So there's a magnet array in here. The field below the magnets is essentially zero, and above is very, very high. The magnetic fluid that's on these peaks will jump across like that. And if we had a continuous stream, the fluid would just constantly flow onto the surface as this magnetic fluid is sucked out. Okay, there we go.
Part of the big problem is that there isn't
okay,
really
so
an effective
my
way
laboratory
to clean
was
up oil
visited
spills
by
in water
the Discovery
yet.
Channel.
But we met some
and
researchers at
I'll
MIT
just show
who
you
have
this.
just found a tantalizing
It's television, you have to
breakthrough.
remember. And I didn't have anything to do with it except to appear on it with my
Shahryar Khosrowshahi's
postdoc.
lab is a mess. There's oil on everything.
I've ruined many clothes.
And now it's just gotten all over his newest creation.
It actually leaked inside.
So that's the Halbach array.
That's what happens when you're an MIT researcher trying to figure out how to clean up oil spills on the ocean.
It's just a messy process.
Shahryar is working on an unusual way to separate oil from water.
This is a vessel, so it's sealed on all ends. And we have permanent magnets that come out from the bottom of the vessel. And then on this edge over here, we have a Halbach array.
The Halbach array is a series of very strong magnets, arranged so that only the magnetic side is the top. Shahryar is going to pour water and then oil in here and hope to separate them using magnets.
Magnetic oil will climb up these permanent magnets over here, and it'll collect at the edge. That's where the magnetic force is the strongest. And then it'll jump over to this Halbach array.
This whole concept was actually the brainchild of his MIT professor. Markus Zahn was motivated by the BP oil spill that happened in the Gulf of Mexico in 2010.
I saw what a terrible disaster it was, and I realized that if I could convert one of the phases, either oil or water, into a magnetic phase, I would be able to separate the two fluids using a magnetic field.
The key to separating oil from water is magnets and nanoparticles.
So this is oil, and it has magnetic nanoparticles in them. And the magnetic nanoparticles have a surfactant, a coating on top of them that actually likes the oil and doesn't mix with the water, so it keeps the oil magnetic.
The beauty of nanoparticles is that they won't weigh the oil down and make it sink. Time to see if it works. The oil is definitely being pulled up, but not across the whole magnetic bridge.
You can see that some of it collected on the right-hand side at the bottom, and that's not what I wanted.
The magnets are so strong, they actually turned around. Shahryar needs to design something that will hold them in place.
This way, they'll stay. Otherwise, they'll try and torque because they don't want to stay in this configuration.
On the new prototype, Shahryar is also adding a pump system.
So that's going to go towards the magnets and get sucked off.
This is the very first time he's tried it.
And then I'll put water. Now I'll run it through.
The water is flowing, the magnets are all working, but the big question is the water coming out of the pump oil-free?
What you saw going in was much darker than now what's coming out here.
Success! Too bad the jar wasn't cleaner.
This dirty water here looks pretty clean.
Yeah.
It's pretty much transparent. And so what you need to do is recirculate it next time.
Yeah.
And multiple passes, and it'll
Yeah.
get all the oil out, and we can probably drink it.
Yeah, I mean, this was only one pass, and with 4 magnets and only one Halbach array. So that's pretty impressive for such a small configuration.
It may be small, but it holds huge promise for cleaning up oil spills in the ocean.
I would just suck it all up with really big suction pumps and bring it on to a treatment facility, presumably on a boat, introduce oleophilic and hydrophobic nanoparticles. Then do the separation by using a permanent magnet array. I would remove the magnetic nanoparticles from the oil because they're very valuable and can be reused. We can then put the cleansed water back into the ocean, and then the oil can be routed to a refinery to process that oil for other purposes.
Permanent magnets and magnetic nanoparticles are going to be a very cost-effective and efficient way of cleaning up oil spills for the future.
Okay, thank you very much.